Okay, a triangle has two sides of lengths 15 and 17, and the angle between them is increasing. So if we've got this triangle, and here these sides are 15 and 17, and here's the same sides, I just drew them with a couple of possible angles inside them, and you can see that as we keep those lengths the same and just spread those two sides further and further apart, as this angle increases, the area inside increases as well. And they tell us how fast the angle's increasing. We're going to need a name for that angle, so I'm going to call it theta. That's our kind of standard symbol for an unknown angle or a variable angle. And they ask, how fast is the length of the third side? So I drew the third side a little fainter because it's the one that we don't know. It's not 15 or 17, it's something else. And that side, of course, is going to have to stretch as this angle gets bigger and bigger. And we want to know how big that third side is. Now, there's a very nice formula that can give us the length of that side, and it's called the cosine law. And it can be written, there's a few different permutations of a and b that can do it for us. The version I have in my head is c squared equals a squared plus b squared, which is nice because it starts out looking like the Pythagorean theorem, but then it contains 2ab cosine. Now, in my head it's cosine c, but for this I'm going to write cosine theta because that is the included angle that we need to talk about here. So for this formula to work, we need to have a is 15, b is 17, or vice versa. Theta is the included angle, and we're trying to find how fast c is changing. So let's get in the numbers we know here. C squared equals, a is 15. 15 squared is 225, plus b is 17, and 17 squared escapes me. I want to say 289. Yep, 289 for b squared. Those numbers are fixed, which means it's okay to put them in as constants right now. Nothing's changing about them. And then we get minus 2 times 15 times 17. That's 30 times 17 is 510. Cosine, and theta is variable, so we have to stick with that as a variable. We can clean this up a tiny bit more if we say 225 plus 289 is, what is that, 514, I believe? 514 minus 510 cosine theta. Okay, and what we're trying to find is how fast that side is increasing, so we want dc dt. And what we've been given is how fast this angle is increasing, which is d theta dt. So you're probably not surprised to hear it's time to do a derivative. I'm going to get rid of these triangles because I have a feeling we're going to need a bit more space. Scoot this up. So if we do the derivative here, we get 2c dc equals, the derivative of 514 is 0, and then we get minus 510 because the derivative goes right through the 510. And what's the derivative of cosine? It's negative sine, so we get negative sine theta d theta. Divide both sides by dt. La 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 la. And we can clean this up a little bit. I want to cancel these negative signs. It would make me feel good to do that. So if we chuck those, we get 2c dc dt equals 510 sine theta d theta dt. And it's dc dt we're trying to solve for. So dc dt should be all of this right-hand side divided by 2c. Let's see if we can do that. 510 sine, what is that angle? They say it's pi by 3, which is 60 degrees. I think better in degrees, so I'm just going to convert that on the fly. D theta dt is pi by 24 radians per second. So there's that. And then we're dividing by 2, and we're dividing by c, which they didn't give us. Tragically, we get to find it. Fortunately, we have a formula that can help us right here. It says c squared, so we can use this. This will tell us that c squared is 514 minus 510. These side calculations are a little bit of a nuisance, but they happen all the time, so all you can do is grin and bear it. Okay, so that theta is our 60-degree angle. Yeah, this should be okay. 514 minus 510 times 60 cosine. Make sure you're in degree mode when you do this, or you'll get weird results. I get c squared equals 259. Don't forget to square root it. Looks like c is 16.09. Which sounds reasonable. These sides are 15 and 17. 60-degree angle means this triangle's almost equilateral, so the fact that all the sides are in the mid-teens is a believable thing. And so our c value down here is 16.09. And so our final number crunch is this: 510 times sine 60, make sure you're in degree mode, times pi divided by 24, also divided by 2, and also divided by 16.09. And I get that c is changing at 1.8. And what are our units here? Centimeters, and our time units were seconds, so this should be 1.8 centimeters per second. And the fact that it's positive tells us that that side should be increasing when we get to 60 degrees.